Welcome, Mr. Sutton here with the AB Calculus 3-6 Extra Practice Number 1 solutions on derivatives of trigonometric functions. To find the derivative on this problem, we're going to have to use the product rule. So that would be u prime v plus uv prime. And setting up the box and ribbon, we've got the two factors, negative 4 cosecant of x and 3x to the fourth minus 4. Now let's get their derivatives. Cosecant is normally negative cosecant cotan. So with a negative 4 out in front, that's going to be 4 cosecant of x cotan of x. 3x to the fourth, that'll become 12x to the third. The 4 gets zeroed out. And now, using our ribbon to put it all back together, we've got 4 cosecant x cotan x times 3x to the fourth minus 4 in a big parentheses. And then we'll have plus negative 4 cosecant of x times 12x to the third. So I guess we could just write minus there. And they said don't simplify, so we're done. To find the derivative on this problem, we will use the product rule. So that's u prime v plus uv prime. Setting up the box and ribbon to organize all this, we've got our first factor, tan of x, up here. And then the other factor, 4x squared plus 3, going in our upper right box. Now to get the derivatives for those lower boxes, tan becomes secant squared of x, and derivative of 4x squared plus 3 is 8x. Using the ribbon to multiply it all out, we've got secant squared of x times parentheses 4x squared plus 3 plus tan of x times 8x. No need to simplify, so we're done. To find the derivative of this function, we're going to have to use the quotient rule. So that'll be u prime v minus uv prime over v squared. Setting up our box and ribbon to organize it, we've got the numerator, 6 cotan of x, denominator, negative x squared plus 3, and their derivatives, which will be negative 6 cosecant squared of x, and this will be negative 2x. Now we'll use the ribbon to put it all back together. We've got negative 6 cosecant squared of x times this stuff up here, negative x squared plus 3 in a parentheses. So that's the u prime v that we just did there. And now for the minus uv prime, we've got minus 6 cotan of x times negative 2x. All of that over v squared, so that'll be all over negative x squared plus 3, quantity squared. We're not simplifying, so we're done. To find the derivative of this one, we're going to have to use the product rule, u prime v plus uv prime. Set up our box and ribbon here. We've got cosine of x and 3x to the fifth plus 5. Derivatives of those will be negative sine of x and 15x to the fourth. Using the ribbon to put it back together, we have negative sine of x times parentheses 3x to the fifth plus 5 plus cosine of x times 15x to the fourth. Not simplifying, so there we are. To take the derivative of this one, we need the quotient rule. So we've got u prime v minus uv prime over v squared. So using our box and ribbon, we've got our numerator, 4x squared plus 5, and our denominator, sine of x, and their derivatives, which are 8x and cosine of x. Using the ribbon to put it together, we've got 8x sine of x, that's the u prime v part, minus parentheses 4x squared plus 5 times cosine of x, that's the uv prime. All of that over v squared, so over sine squared of x. To find our derivative on this one, we're going to use the quotient rule. So I've got u prime v minus uv prime over v squared. Setting up the box and ribbon, we have our numerator, negative x cubed plus 4, and our denominator, secant of x. Derivatives of those will be negative 3x squared, and this will be secant of x tan of x. Using the box and ribbon to put it together, we've got negative 3x squared times secant of x for the first part of this. Now we'll be subtracting parentheses negative x cubed plus 4 times secant of x tan of x, so all that stuff. And my v squared on the bottom, that's going to just be secant squared of x. For this one, trying to find the derivative, we're going to use our quotient rule for this. So I've got u prime v minus uv prime over v squared. Box and ribbon time. So I've got my numerator, secant of x minus cotan of x up here. Denominator is 3 cosecant of x plus tan of x over here. And now the derivatives on these. So we have a secant x tan x, and this will be, let's see, cotan of x is normally negative cosecant squared for the derivative, but we already have a negative, so that's plus cosecant squared of x. Now over here, derivative of this stuff, this will be negative 3 cosecant of x cotan of x, plus the derivative of tan, which is secant squared of x. So it's time to use the ribbon to put all this together. So let's see here. We've got u prime, so secant of x, tan of x, plus cosecant squared of x, all that stuff right there, times v, so we're just going like this. So this will be parentheses 3 cosecant of x plus tan of x, minus, going this direction now, secant of x minus cotan of x in the parentheses, and then times all this stuff down here. I'm not going to say it, just put it in parentheses. All that over v squared, so that's going to be 3 cosecant of x plus tan of x, quantity squared down there. And this is where you really take their word for it when they say don't simplify. On this problem, we're trying to find the limit as h approaches 0 of all this stuff. So this is just the limit form of a derivative. The original function is whatever this pi over 6 plus h is getting plugged into, so cosine. And the derivative of that is going to be negative sine of x. Now, because we have this pi over 6 in here with the h instead of just x, they actually want us to plug pi over 6 into this derivative. So negative sine of pi over 6, that's going to end up being, let's see here, negative 30, because this is really sine of 30 here. So negative 1/2. On this problem, we're trying to evaluate this limit as h approaches 0. You might recognize this is the limit form of a derivative. So really in these situations, we just need to find the original function and take its derivative, possibly with some value plugged in. Original function, based off of the structure here, is going to be tan. Whatever the x plus h is getting plugged into is the function. So tan of x, and the derivative of that is secant squared of x. Now because we have a 3 pi over 4 in here, that means we're plugging 3 pi over 4 into this derivative. And it's a constant, so you could leave it this way. If you really wanted to simplify it, this is really 135 degrees. Secant is really 1 over cosine of that. Cosine of 135, that would be negative root 2 over 2. So secant would be negative 2 over root 2. So we're squaring negative 2 over root 2. So that's going to be, let's see, 4 over 2, which comes out to 2. On this problem, we're trying to evaluate this limit as h approaches 0. This is the limit form of a derivative. The original function in this case is sine of x, whose derivative is cosine of x. And because we have a 5 pi over 6 instead of just an x plugged in with this h, that tells us that we're plugging 5 pi over 6 into this derivative. So cosine of 5 pi over 6, that's really like 150 degrees. So cosine of that, that would be negative root 3 over 2. And that's our answer. On this problem, we're trying to evaluate the limit as h approaches 0 of all this stuff. So this is one of those limit forms of a derivative. Whatever the x plus h is getting plugged into is the original function. So in this case, that's tan of x. And it's kind of hard to see with this radical 3 over here, but if you took tan of 2 pi over 3, you would end up with radical 3. All right, actually it'd be negative radical 3 because it's normally minus whatever is over here. So derivative of tan of x, which is what they want us to take here, that would be secant squared of x. And now we actually have to plug in this 2 pi over 3 for that. So let's see here. This is really 120 degrees. Cosine of 120 would be negative 1/2. So secant is the reciprocal of that, so negative 2. But we're squaring that because of this square here. So that ends up coming out to a grand total of 4.